Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. Today, we're covering big news out of Meta, OpenAI, and Google. And we're also going to share our thoughts on AGI and exactly where we each think we are on the timeline to achieving artificial general intelligence. To help me make sense of it all, I'm joined by my two amazing Kung Fu AI colleagues, my co-founder and distinguished engineer, Dr. Zizi Tsai, and VP of Engineering, Michael Wharton. All right. Great to see you guys. You ready for another episode?
So ready.
So great
All right.
to hear.
All right, let's just jump right in. I'm going to talk about what I think is probably the most anticipated model of the year, which is GPT-5. It's been almost 2.5 years since GPT-4 came out. This was definitely, I think this is one of those situations where OpenAI put themselves in a little bit of a corner because there was so much hype. Almost anything they came out with was going to be a little bit of a letdown.
Yeah.
A little bit of a letdown.
Yeah, it was shown as a big whale compared to GPT-4, right?
Exactly. That's exactly right. And so I've spent, it came out a couple of weeks ago. I think the timing on this episode is great because it allowed me to do a bunch of research and a few things. I think there's a general consensus even 2 weeks out that the release was a bit botched. And it wasn't so much that the model was a huge disappointment, but there's an element to that. It was just a lot of the confusion. They removed some of the pre-existing models. Did you guys see that there were people, like especially in some user groups, that were really upset about 4.0 being taken
4.0
away?
is really popular. Yeah.
And it's a very almost like sycophantic model. Everything's a great idea that you have. And I saw some people saying, they felt like they lost a friend. There were issues with the router. One of the things I think OpenAI was trying to accomplish with this release is moving away from having users select the model. That's not a great choice. I mean, what's the difference between, O3 and Turbo and Mini and things like that? So the router, which was supposed to take in your question to decide whether to do a fast response model or a thinking model, that was broken. So a lot of the questions that needed more thought went to the fast thinking model. There's some other things too. It was pretty underwhelming, I think, from a capability perspective compared to what people expected 5 to be given all the time. And that's led to a bunch of what I kind of feel like real sort of hype backlash. And it's gone beyond just GPT-5, in my opinion. I actually want to ask you guys about this in a second. There's this idea that OpenAI has lost the lead, or they failed, or the model wasn't everything was expected to be. Maybe AGI is now, the timeline on that's been pushed away. Maybe scaling doesn't work anymore, or the AI bubble is bursting. All these sorts of really negative trends. So before I go any further, I want to ask you, have you guys had a chance to play with GPT-5 much yet? And if so, what are your thoughts?
I personally am a big Anthropic guy. I mean, just because I'm a developer, I typically use that for most tasks. So I've looked at a lot of examples. I've obviously read Gary Marcus's scathing review, but I haven't really played with it much other than just a few little test prompts.
Are you using Claude for your non-coding tasks as well?
Yeah, I just have the desktop app and use it for everything.
Yeah. How about you, Zizi?
So I've used GPT basically every day. And between Claude and GPT-5, I kind of use them half and half. Claude is really good at coding. So, I use Claude Code. Yeah. And that, the Opus model is really, really good. And Sonnet is not bad either. For GPT-5, I totally agree. I feel like, for common, like simple tasks, I don't feel there's a big difference compared to, 4.0 or,
Yeah, I agree.
And 0.3 is really, really good.
Right.
Yeah, I know the naming can be really confusing.
I know.
But then, GPT-5 Pro, if you have the patience, it is really, really good on some of the, more deep thinking tasks. So like, if you're trying to brainstorm about some mathematical theory, some proofs, and trying to do some survey. And I do find it to be, giving me some of good insights. And it's a great learning tool for me now.
Yeah. That mirrors my experience as well. I feel like when the day-to-day stuff, not a big change if I'm asking it to summarize something or like that, but when it kicks into thinking mode, the results have been great. And I'm finding, they advertise that there were less hallucinations. I'm feeling like there are less hallucinations on a personal basis. All right, so I went and did an analysis of its performance on different metrics, and it's pretty interesting. Surprisingly, the jump in performance between April 2024, which was GPT-4 Turbo, and April 2025 to GPT-03, that was bigger than the jump between 3 and 4, which is kind of surprising. I think we forget how, bad 3 was relative to, and in hindsight, really saw how weak 4 was. Few metrics. On the multiple choice general knowledge, MMLU, it went from 56 to 84%. This is GPT-4 versus 5. So big jump. On the SWE software engineering, went from basically 1% to 65%. And then on the AIME, the high school level math, it went from 7% to 87%. So these are pretty meaningful jumps. Probably more interestingly, the meter challenge, essentially, that measures the ability for AI to carry out long tasks. GPT-5 is now the top model there, and this is really impressive. It has a 50% time horizon on tasks, up to 2 hours and 15 minutes, which is really kind of astounding. And by contrast, GPT-3 could only handle tasks of a few seconds to a minute, and 4 could go up to 10 minutes. So, I mean, this is a significant jump in the last couple of years. So here's my takeaway on this. I think the reality is O3 was so strong, right, that I think it was just necessarily going to be a letdown with 5. And I also think that OpenAI has not come out and explicitly said this, but it seems pretty clear to me that they were focused a lot on reducing inference costs. This was about trying to at least keep parity for most average users, but dramatically reducing the inference costs. And then other things like getting rid of model selection and having the router and stuff like that. And so I think that net, it was sort of a botched release, but my guess is it's going to get the monkey off OpenAI's back. They've now figured out the naming, and now they are sort of clear to maybe take a big swing on the scale front again. All right, so I've got a question for you guys. How does this affect your timeline on AGI? Meaning the fact that GPT-5, I think it's fair to say it's more evolutionary than revolutionary. Does that pull back, push forward your timeline in AGI? And I know there are some people that maybe even think we've really already crossed that threshold and we should qualify these models as AGI. I'd love to hear what each of you think.
Yeah,
That's
a great question. Yeah, I think different people have very different definitions of what AGI is. And for me, I have always thought, AGI is not near, because to me, an AGI needs to be able to complete a simple task for a human, like, hey, make a coffee and bring it to the table.
Oh, so you're thinking like embodiment. You want physical embodiment. Okay.
Yeah, it needs to be able to interact with the real world. Although, the language intelligence is great, the math coding capability is great, but everything is it's confined in a digital world. Mm-hmm. It doesn't really deal with the messiness of the real world. And I view like the language, math, coding ability as a tip of iceberg, kind of in an ivy tower.
Yeah.
But the thing that's underneath, the physical intelligence, the spatial intelligence, like grabbing a cup reliably, not breaking it.
Yeah.
You operate in the coffee machine and maybe it's dirty, maybe you need to wash it. So many messiness in the real world that I feel like.
Okay, so you don't think we have AGI right now. Do you feel, specifically with GPT-5, do you feel that pushed out when you think we'll get to AGI, or it didn't really affect your timeline?
I don't think it affected my timeline. I would I'm more interested in following the world model, the video generation type of work stream. I feel like that can unlock a lot of the things that's under the tip of the iceberg.
Okay. Yeah, Michael, how about you?
Honestly, it's going to be pretty similar. Always in these AGI conversations, I always tend to lean toward, okay, let's define it. What are we talking about? I kind of suspected that there would be some sort of stalling of performance, at least without some major algorithmic sort of upgrade.
Yeah.
So, it's interesting to watch it play out. I mean, there's the biases that these models have, like the intrinsic features of the way that LLMs work seem to be consistent regardless of scale so far. Like they have these really strong priors, and I know Gary Marcus is the go-to naysayer for all this stuff.
Yeah.
And, he shows these photos in his latest Substack post that's like, oh, look, how many legs does this zebra have? And it's like a photo of this zebra, and it's clearly got 5 legs, but there's such a strong prior around how many legs a zebra should have that you just can't get it to admit that there are 5 legs.
Right.
There are other things at play there. But, I really do think that the spirit behind the AGI question is, can this do what humans do? And I think that we've come a long way for sure. And there's still a ton of distance that we need to go. And it's just kind of like I don't think there's an AI winter ahead of us.
Okay. But all right. Same question for you. Did this push out your timeline for AGI or not affect it?
I don't think affected because it feels kind of like in the noise in terms of how far we still have to go.
Okay. All right. This is great because I'm going to take a contrarian perspective, which
I
is
love it.
Love to hear it.
I genuinely feel like we've already achieved AGI. And I believe that based upon what I would have defined AGI as 10 years ago,
so we moved
20 years ago. That's it. I think we're just moving the goalpost.
Yeah.
If you go all the way back to Turing.
Yeah, Turing test.
In the mid 20th century, the whole idea was you would interact through text prompts because you didn't want the embodiment problem to be a challenge. Again, seriously, 10 years ago, if you would have said, give me your criteria for AGI, I think we'd have checked all those boxes, right?
I totally am with you on that.
And it's because these models now have broad general intelligence. You can interact with them and they can converse increasingly at an expert level on pretty much any topic. Now, they'll make mistakes, but I actually think that's a bit of an element of the nature of intelligence, that sort of fractal boundary of intelligence. And if you think about humans, I mean, I like to think I'm a smart person. I'll do the dumbest things occasionally, and I can't believe it. I will misspeak, or I'll walk into the room and forget why I went in there. And I don't think that those lapses disqualify me as having general intelligence. So this is, I know this is a little bit of a fringe take, but you nailed it. I think it's mostly we've moved the goals, and I think it's fine. This is the reason I'm pretty excited, which is take ZZ. You're like, well, you want AGI to have full embodiment and the ability to move around a 3D world. The fact that we're even moving the goalposts to that point now show how much progress we've made.
Yeah, totally agree.
What about the? I guess this is to get to a broader conversation. I'll try to keep this a little brief, but I feel like with agents, except for some very narrow tasks that are rote where the domain is unchanging. You can't let these things just go run off in the wild and do their own thing. There's still always got to be some sort of human supervision. And to me, it feels like there's some key, call it AGI threshold or something, beyond which humans don't have to be involved in things that they normally are.
Yeah.
And it feels like we really have kind of like bumped up into a little bit of a wall there.
Yeah.
I don't think there's an actual wall there. We'll bust past it.
Right.
But there's something about still having to review every line of code that gets generated in like my IDE that feels like, if we had AGI, I feel like I wouldn't need to do that.
Right. Yeah. But see, all right. So last thing, the reason I feel comfortable saying this is we're talking about general intelligence.
Yeah.
Do we review human code?
Yeah, that's a great point. That's
right.
That's a good point.
We have to.
Touche.
So, now maybe ASI, right? Super intelligence. No.
That's a new goalpost, though.
That's the new goalpost. It should just handle it. Okay. ZZ, I know you've got some news on the world model front for us.
Yeah, so I got two quick updates that I am really excited about in the last month. Both are about world models. Well, really, action condition video generation models. The Genie 3 that came from Google DeepMind.
So impressive.
Yeah, I watched their demos. That's really great. I don't think they have APIs accessible yet, but the demos definitely look super impressive. So it's a action condition video generation model. Basically, you can think about it as you can write a prompt and it will generate a world where you can just use your arrow keys or mouse to move around and then explore the world, and in real time, because I believe they optimize their model to be generating at 24 frames per second now.
Yeah,
at 720p kind of resolution.
The video, and we'll put a link in the podcast, but the video where they showed the perspective of the man painting the wall.
Oh,
you know what I'm talking about?
Yeah.
And it has memory. I've shown that video to, I don't know, half dozen people, and every single person that saw it asked me about halfway through, hold on, is this AI generated? They thought it was real.
Yeah. And there's another demo that I really like, which is you can control the player kind of in a first person view and go towards a water puddle, and then you move forward, and then you look down, and then you can see the foot step into the water puddle, and then the ripple and everything that looks like so real.
Yeah.
Another crazy example is where it's like a world in a world. So I think someone prompted Genie 3 to imagine Genie 3. So in that video, there's a person looking at a computer screen, and on that computer screen is Genie 3. I mean,
it's incredible.
Generating there. So yeah, that is super interesting. And another adjacent update is called Huanyuan Gamecraft. It's also a world model. It's an action condition world model. It's an open source one from Tencent. So what's interesting there is that they made some architectural innovation where they basically map the mouse movement or the arrow movement into kind of camera and movement space. And then they also did something with the kind of the hybrid history, so that they can keep generating a long video without drift, which has been a challenge before.
Yeah, because I believe the Genie 3 videos, they're what, a minute, 2 minutes max, something like that?
Yeah. So
I believe that's right.
Yeah. Between Genie 2 and Genie 3, I think the length of the video without drifting, without having unfeasible kind of conditions has improved a lot. And I think they trend, for the Huanyuan Gamecraft, they trend on about 1 million gameplay videos from about 100 games. Yeah, that's a super interesting model.
So there are no tricks under the hood to enforce consistency or anything like that. It's truly just kind of like an end-to-end data in, model out kind of situation.
Yeah, I believe they don't have an explicit geometry, 3D geometry. Everything is just learned from the pixels.
And I remember same thing on the Google model, the Genie 3, that they said that the consistency was emergent. Which to me is just amazing. I mean, that's when things like that happen, it makes me feel like we're on the right track.
That's a bitter lesson, right?
That's a bitter lesson, baby.
Yeah.
And related to the AGI topic, if we want the AI to have embodiment, to really understand the world, well, you need to simulate the world first. Well, that's not my words. That's Elon Musk's words.
Yeah, that's great. That's awesome. All right, Michael, what do you got?
I was going to talk a little bit about Dyno V3.
Good.
So yeah, it's from Meta. Awesome. And I feel like with Meta, it's finally crossed that threshold where it's more comfortable to say Meta than Facebook.
Yeah.
I feel like same thing with like the Twitter X thing. Yeah, they're Meta now. Good job. But yeah, so it's a self-supervised image encoder, meant to be very, very general purpose, much like Clip, which we use for image embeddings for tons and tons of things. But they had a clever little innovation that I think was kind of like the secret to unlocking a little bit of performance with dense feature performance. So for things like really fine-grained image segmentation or, things where you need really dense features. Apparently it's this really big deal with self-supervised image encoders where if you train them for a really long time, you'll notice that if you pluck out a set of weights in the middle of training and then you fine-tune it for either a classification task or something that requires dense features, classification performance just improves monotonically, but eventually semantic segmentation or those like dense performance sorts of tasks will peak out and then drop off and start degrading.
I want to make sure I understand. This will happen when you're fine-tuning it, period, or if you remove some weights.
It's basically like let's say you train for 100,000 iterations, but you've still got some way to go on the self-supervised task.
Yeah.
If you use that as a basis for a fine-tuned task, it's going to do great with classification, great with segmentation. But the more you train those features, the more they're useful for global tasks and not local tasks.
Interesting. Okay.
So like, are the features that are being extracted useful for everything?
Yeah, it sounds like they're losing the very fine-grained features somehow.
That's exactly it.
Okay.
Yeah, so apparently this is like in the self-supervised image encoder world, this is like a very known limitation. And what they did to get around that was this thing called gram anchoring.
No, I don't know this. Okay.
I hadn't heard of it either. So the idea is that this gram matrix is what they're calling. You take the feature map from one model's output, and then you do pairwise comparisons of all the features. So it's a n-squared sort of problem. Like if you can imagine a vision encoder and you have the 16 by 16 feature map or for the patches or whatever your architecture is. If you were to do pairwise comparisons between all of those features, that is if you enforce it to keep that consistency as you're training, then those dense features don't degrade.
Oh, okay.
Sounds, I know it's kind of convoluted.
And when you say you're comparing those patches for consistency, I mean, is it like a dot product? Do you know specifically what they're doing?
Literally just like cosine similarity.
Okay.
Yeah.
Okay.
Yep.
And that's all it takes for it to not sort of average out those fine-grained features.
Yeah, they'll literally pluck out, like as they're training, they'll just take one of the earlier models and that becomes the teacher. And then as they continue training, those downstream become the student. And then they just enforce consistency relative to a previous teacher.
I misunderstood.
Training progress. Okay.
I was thinking within the same model. This is over time. You keep the consistency over time.
Yep.
Oh, interesting.
Yeah, it almost feels like when you project the image into like 16 by 16 kind of latent vectors, and in the latent space they have certain geometry, certain relative position.
Yep.
And maybe over time or during the progress of training, you don't want them to be just randomly shuffled around. You want to keep it kind of invariant, like their relative position in the latent space to be consistent. Yeah,
that's
I can feel
exactly
that.
right. Yeah, you want the structure. It's almost like that Platonic representation hypothesis paper that we've all been talking about.
Yeah,
like there's some structural consistency of that embedding space that you want to maintain roughly at the point that it starts doing really well on those semantic segmentation or dense tasks.
Yeah.
And the results are kind of mind-blowing. They tested against a bunch of different things because it's an encoder that's universal. So yeah, I'm not going to get too into the weeds with the evaluations. But the takeaway is that anytime dense features are important, it blows the competition out of the water. So things like semantic segmentation, there's no supervised training with this whatsoever. And there's a figure, I think it's figure 3, and it shows if you look at the feature map on this, it's like a really, really crazy photo of like a fruit market, like a fruit stand at a market. It's got apples, bananas, oranges, cantaloupe, whatever. And if you look at you just pluck one pixel out, and then you take some similarity with all the rest of them, it's basically got a semantic segmentation model built in already without any sort of fine tuning because it's that good at that structural consistency.
Oh, wow. Okay, I did not see that coming.
Yeah, you can use it for really amazing sort of segmentation without any sort of fine tuning.
Wow, and this is open source.
And it's, well,
yeah, with an asterisk.
Yeah, I mean, you have to give them your name and your date of birth. And that was kind of like a scandal.
Yeah.
It's meta. They want your data. So.
Yeah, exactly.
But yeah, it's cool.
That's great. All right. Well, I think we'll call it there because this was a really, for me, I think a pretty exciting month. And I think we covered the 3 most important things that have happened. GPT-5, the Genie 3 model, which I think is actually just groundbreaking in an amazing way. And then the stuff coming out of it with Dyno 3. This is great. All right, guys, I appreciate your time.
Thank you so much.
See you next time.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.